Dear friends, in this video we are going to discuss about the different types of load cells, strain gauge load cell, pneumatic load cell and hydraulic load cell, which is an important force measuring equipment commonly used from low weight to very high load. In simple terms, we can say this load cell is a force transducer. It is a force transducer. Force transducer is an electrical device which converts force into electrical signal. The force can either be a tension force or a compressive force or pressure or torque. As electrical signal changes with the force in load cells, the same could be standardized to represent a physical parameter like weight. So this is the main concept, main principle behind the working of load cells. Let us see different types of load cells. First one is a hydraulic load cell. The hydraulic load cell works on the principle of force balance principle. If you look at the diagram, we can understand that when the force is applied on the platform, that is over the piston will exert a pressure or force on the diaphragm. The diaphragm is having the flexibility, that is, it will deflect, it will undergo change. When it moves downwards, that is, the diaphragm moves downwards, the liquid in the tube which is connected below the diaphragm in the container will also move with the pressure, and the same pressure will be read through the pressure gauge. So as I have told, we have to standardize this pressure to represent the physical parameter of force or weight. Based on this calculation, we can find the force applied on the object. So this is called the working of hydraulic load cell. Second one is a pneumatic load cell. This is also working on the principle of force balance principle. In the hydraulic load cell, we have used the liquid, whereas in the pneumatic load cell, we are going to use the air. As we have seen in the hydraulic, here also the force to be measured will be applied on the top side of the diaphragm. So the diaphragm deflects and causes the flapper to shut off the nozzle opening. Now an air supply is provided at the bottom of the diaphragm. As the flapper closes the nozzle opening, a back pressure results underneath the diaphragm applied force when calibrated. This back pressure acts on the diaphragm, producing the upward force. So the diaphragm comes back to its original position. At this stage, the corresponding pressure indicated in the pressure gauge becomes a measure of the applied force when calibrated. If you look at the diagram, you can easily understand when the force is applied on the diaphragm, it gets reflected, and the same is shown in the pressure gauge. And again, air will be supplied from the bottom, and the diaphragm will come to its original position. So the load is applied, wetting load is applied. The bleed valve will close the container. By means of the manometer, we can measure the pressure also. This is also another way of measuring the pressure. The third diagram, we can see how the thrust force is applied, how the pressure is recorded on the pressure gauge, because of the compressible pressure acting on the cylinder. So these are the various ways and methods of measuring force acting on the substance by using air as the medium. That's why it's called as pneumatic load cell. Another important type of load cell is, almost in all the load cells we have this strain gauge. Strain gauge is nothing but convert the force into electrical signal. The strain gauge is made up of deforming materials like aluminum in the form of strips, thin strips packaged in a metal container. When the force is applied on the metal container, this will elongate or it gets compressed, and the strips gets elongated or it will undergo the deformation, which will result in change in resistance. That resistance will be measured by using the Wheatstone bridge. If we take one strain gauge, there will be 4 resistors. 4 strain gauges will be there. If we connect all the 4 strain gauges, that will become Wheatstone bridge. Commonly, copper and nickel are used in strain gauge construction. So if you look at this, we can see 4 strain gauges in a Wheatstone bridge configuration. The electrical signal output is typically very small, in the order of few millivolts if we use only one strain gauge. So that we are using 4 strain gauges. So the output can be digital or analog depending upon the application. The working principle of strain gauge is deformation results in change in electrical resistance through tension or compression forces. Welded sensor utilizes bonded strain gauges connected in a Wheatstone bridge circuit. The output is derived from imbalance of the bridge circuit as load is sensed by sensor. So this load cell is working on the principle of Wheatstone bridge, where we have 4 strain gauges, 4 resistors are connected. If no load is applied, the output volt will be 0. If the load is applied, output voltage will be there. We have to convert that output voltage into digital, and we can say the force applied on the substance or object. So this is the diagram of the Wheatstone bridge. The construction of a strain gauge load cell. If you apply the load cell, the strain gauge will get deformed. There are 4 strain gauges in a strain gauge load cell in the form of Wheatstone bridge configuration. If there is no load, the output voltage will be 0. If there is a load, the output voltage will be measured, and correspondingly it will be converted into analog and digital values, so that we can easily measure the load applied on a substance or force applied on a substance. So this is the working of Wheatstone bridge. So in this video we have seen 3 types of load cells: strain gauge load cell, hydraulic load cell, and pneumatic load cells. Thank you for watching this video.